Okay, jumping straight into question 3, we've got a sigma notation question here. Right, so we're told that the sum of this from y equals 3 to 10 minus the sum of this expression from y equals 3 to 10. Now I think in this case it would be best to start writing down what we know. So 1 over, and y starts at 3, so the first term is 3. Then the second term, and since we're having sigma notation, that means adding. Right, so let's just write the plus sign. So plus, and then the second one is when y is 4, right? So y is 4 minus 2, plus 1 over 5 minus 2, and we see the pattern continues, right? Up until we get to 1 over 10 minus 2. Right, so that's this first part. Then we get minus, and we do the same with the second one. So the first term is 1 over 3 minus 1. Plus, and then 1 over 4 minus 1, plus 1 over 5 minus 1, and again the pattern continues until we get to plus 1 over 10 minus 1. Right, so we see something interesting is happening here, but let's just quickly rewrite this in simple fractions. So 1 over 1 plus 1 over 2 plus 1 over 3. So we get all of these. I'm going to write all of them down because I want to show something. 1 over 6 plus 1 over 7 plus 1 over 8, right? So that is the first part. Then minus, in the second part, I'm going to write all of them out as well. So 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5, 1 over 6 plus 1 over 7 plus 1 over 8, oh, 7 is a bit ugly, plus 1 over 9. Right. Okay, so we see what's happening here is we see that a lot of things can cancel out. So we've got a half minus a half, a third minus a third, and we see that pattern continues, fourth minus a fourth, fifth minus a fifth, and that will take us all the way to here. So all that we have left is 1 over 1 minus 1 over 9. Yeah, and 1 over 1 is the same as 9 over 9 minus 1 over 9, so 8 over 9. And I think this is probably one of the easier ways to do this question, even if you don't write everything out. But please let me know if you found another way to do it. Another way could be to combine these into one sigma notation. I think it might take a bit longer to do it that way in this case, but please let me know if you found some other cool way to do this one. Right, question 3.2, only second question for this video. I mean, we only have 2 questions for this one. We get told, this is the question. A steel pavilion at a sports ground comprises of a series of 12 steps, of which the first 3 are shown in the diagram here. Now each step is 5 meters wide. Each step has a rise of 1/3 of a meter, that one, and a tread of 2/3. So the tread where you step on, right? 2/3 of a meter, as shown in the diagram. The open side, which is shaded on the sketch, so that means this part, and on the other side as well. We just can't see the other side. Oh, sorry, just dropped my pen. So this is the open side, right? Shaded in the sketch. On each side of the pavilion must be covered with metal sheeting. Calculate the area in meters squared of metal sheeting needed to cover both open sides. Right, so what we need to do is we need to find the area of this and multiply it by 2, because that's the same as the area on the other side, right? Okay, and now how to calculate this area? I think that is where the interesting thing comes up. So I'm going to do it this way. I'm going to say, let's first calculate this little area here. Right, this part, that part, and I'll make that my term 1. So term 1 will be that area. Then, okay, well let's write that down first. So term 1, so that area we've got 1/3 times 2/3. So 1 over 3 times 2 over 3. Right, the second term I'm going to make this area. Right, so that's term 1, that's term 2. So this is going to be 2 over 3, so 1 over 3, another 1 over 3. 2 over 3 times 2 over 3. 2 over 3 times 2 over 3. and term 3, and then from there we can just check what is the pattern. So term 3. So that'll be, you guessed it, this one. Right. Oh, that is disgustingly ugly. Okay, so that's 3/3 times 2/3. So 3/3 times 2/3. Okay, let's write this down. So 1/3 times 2/3, 1 times 2 is 2, and 3 times 3 is 9. The second term, 2 times 2 is 4, 3 times 3 is 9, and the third term, 3 times 2 is 6, and 3 times 3 is 9. Okay, so now we need to decide which type of sequence or series do we have here. Right? Are we multiplying the same thing, or are we adding the same thing each time? And in this case, we're just adding 2/9 each time, right? Because if we can check that quickly. Let's check that in rough work. So we know that term 2 minus term 1 must be equal to term 3 minus term 2 if we're adding the same thing each time. So let's do this. So 4/9 minus 2/9, right? Term 2 minus term 1, and let's calculate that. So that gives us 2/9. Then term 3 minus term 2, so that's 6/9 minus 4/9. What does that give us? 2/9. And these are equal. So we know we're working with an arithmetic, with an AP, right? So this gives us an AP, arithmetic progression. And what do we want to do with these terms that we have though? So term 1, that's the area of the first step, area of the second step, area of the third step for term 3, right? And we have 12 steps. So what we want to do is we want to find the sum of the first 12 steps. And that'll give us one side's sheet plating. Okay, let's do that. Let's do that. What color should we use? Black. Let's use black. Right, so we want to know, in this case, so we know this is an AP. So our A is our first term. And our common difference is also 2/9. Right? Our first term is 2/9, and we're adding 2/9 each time. And we want the sum of the first 12 terms. Okay, so sum of the first 12 terms. Well, let's do what is Sn first. Let's just do to remember the formula. Right, so the sum of the first n terms, it doesn't matter what n is n/2 times 2a plus n minus 1 times d. Now if we know the first and the last term, we can make it a slightly easier equation here. But I'm just going to do this one because this is one that we use more often. Often we don't know what the last term is. Okay, so let's do the specific one here. So that'll be the sum of the first 12 terms. So S12 equals then 12/2 times 2 times A, which is 2/9, plus n, which is 12, minus 1 times D, which is 2/9. Alright, and now we can just calculate this. I'm going to do it without a calculator. I mean, you could just type this whole thing in your calculator. I'm just going to do it without one. This gives us 4/9 plus, this is 11, so that's 22/9 equals 6 times, and this gives us 26/9. Right, that can simplify to a little bit. What does that give us? 52/3, I think. Well, let me actually maybe just check this on the calculator really quick, just so we have the right thing for going forward. Okay, so 6 times 26/9. That gives us 17.33. That's right, so that's fine. Okay, so this is correct, and that is the sum of our first 12 steps. Right, that's how many meters it is. But now we need both sides, right? So that gives us one side. So what that tells us is this whole one side will need 52/3 meters of sheet metal. But on the other side we'll need the same. So we'll say, so the total is equal to 52/3 multiplied by 2 meters. Alright, So that gives us 104 over 3 meters. And just to see how to round off, maybe we'll do that. Let's just quickly round that off here. I get it in decimal form. So 104 divided by 3, that is 34.67. So 34.67 meters squared. Remember the square. That is actually true. Right, and that's it for question 3. We'll dive into question 4 pretty soon.